Okay, I think we are live. Waiting to see. Hopefully, we are live. Some teething problems to begin with. There we go. We are good. We are good to go. So this is the first attempt at live streaming the creation of a scientific paper, and it's going to be a combination of coding and writing, and both I'm equally terrified, but I think this is going to be a really handy experiment, really interesting experiment. And if you're interested in knowing why the hell I'm doing this, check out the blog post, which is in the link, which is in the bottom right there, for the reason why I'm doing this and attempting this. But to give you a very, very quick overview, I'm really, really interested for this particular project in how we can actually create synthetic data sets of real data. What Now there's a real big problem when it comes to we want to be able to share data. We want to share our data sets, but of course, there's issues of confidentiality. So, of course, it'd be better if we did share our data, but we can't do that. But there is an alternative. There is a way that we can actually create synthetic data sets which share the same characteristics, the same summary characteristics, and the variables have the same relationships between these variables. So we can actually share these, and some of the benefits are that other people can actually test models. And if they have interesting models from the datasets or from the synthetic datasets, they can actually notify the authors going, hey, I've got an interesting hypothesis. How about you run this? So it's really interesting when it comes to hypothesis generating research. And it's also, as a reviewer and as a reader, sometimes I read people's analysis scripts. It's great that they're sharing it, but I have no idea what they're actually doing. But if you're actually going to be sharing your analysis scripts alongside your data, it's very easy to actually see what is actually going on. So I want to create a tutorial on how to actually create these synthetic data sets. Some people have used this in the biobehavioral sciences, but there hasn't actually been any tutorial papers. So I'm going to give it a go. I'm going to see how to actually create these things, to validate them, so people can actually share their data sets. I think it's going to be incredible. Imagine in the future a situation where everybody, regardless of privacy issues, can actually share a synthetic version of their data sets. Of course, it's not going to be the same as sharing the actual data, but it's going to be much better than not sharing any data at all. Okay, let's get started. We're going to be using the synthpop package. And first, I thought I'm going to be using a data set. I'm very interested in oxytocin research, so I'm going to be using a data set which is looking at the role of, which I'm very familiar with, and it's an open data set looking at the role of oxytocin and spirituality. Does intranasal oxytocin increase feelings of spirituality? I've gone through this data set before in a tutorial actually comparing Bayesian hypotheses, testing alternatives to sort of common null hypothesis significance tests. And I think it would be interesting to use the same data set to actually see what we can do there. Okay, so we're going to be using the synthpop package, and I'm going to be looking at the documentation here. Now, the documentation for synthpop is fantastic. I really appreciate it when developers of packages go to the trouble of doing these things. Okay, so let's go installing. Synthpop. Okay, synthpop is there, and I want to import a data set, import the oxytocin data set that we have. Okay, so we're going to call this OT dat. Find the file there. It is read underscore. Hopefully I have the packages installed. Reader, no, probably not. Let's find out. Reader, nothing like coding live. It's incredible. Okay, read CSV. Of called it OT.dat in my library. File type equals CSV. Let's see if this bad boy works. Oh, forgot this. Yeah, it's going to be a very, very interesting experiment. Unexpected symbol. There we go. What? I don't even need that. What am I doing? All these packages. Okay, there we go. Let's have a look. Clean this up a bit. Okay, let's have a look at this file. So, I've worked with this dataset before, but not in the context of doing synthetic data. So let's have a look and see. Okay, so for this particular dataset, for this particular study, participants were either given a spray of intranasal oxytocin or placebo, and then they were asked, how spiritual would you describe yourself? From memory, the original study, the main outcome, or the main reported outcome, was that once you account for a religious affiliation, as in how often you go to church or whether you're affiliated to a church, oxytocin seemed to increase self-reported measures of spirituality. And full credit to the authors, they actually released all their data online. So it's very easy to actually go through and verify their analyses, which I did. And everything, at least from what they reported, was fine. Okay, so we're going to look through and we got this data set here, age, oxytocin condition, affiliation, and the main one that we're looking at, or the main outcome, is this SPI_1_L, which is basically, from memory, it's a scale from 1 to 7, where people will ask how spiritual they are. So that is the main outcome. So what we want to do, or what I want to do here, is saying, okay, can we actually create a synthetic version of this data set, which actually maintains the same properties of the original data set? Okay, so we've imported this. Now let's go back. We're going to go back to the simple example from the synthpop documentation here. Okay, so what they've done is they've created a smaller data set of variables, which seems to make sense. So we'll do that. Except we're not going to do that because we have different variables. So what we're interested in is... let's have a look. OT condition. Yep, we do want that. What else we want? Age. That's interesting. I believe it's a capital A. Yep. Got to get those cases right. Now, what else we got? Religious affiliation, because that's important, because that is an important covariant. Hope you're doing fine wherever you are watching. It is summer here in Norway. Very, very good weather. But I'm inside. I'm working, but it's fine. Okay, so SP1. SP1. Lowercase. Yes. SP1L. SP1_1_L. Is that a capital L? It is a capital L. Okay. I think... yeah, we'll leave it at that. Okay, so this is just going to create... so what they've done in their example here is... yep. Okay. So run that. And copy and paste that. Cool. So that should create new data set here. Double check. Let's confirm. You know what? It's going to be confusing. So I'm just going to call it S for short. Run that again, just so we don't get those two mixed up. Okay, cool. So now we have this data set here, which just has the four variables that we're interested in: oxytocin condition, age, religious affiliation, and the main outcome of self-reported spirituality. All right, so now what we're going to do is... okay, so we're going to do the basic analysis. Let's set a seed as well so we can reproduce this. Yeah, it seems fine to me. Setting the seed there. Okay. Now, let's run that, and we'll call it OT synth. Okay, this is the data set. Make it a bit shorter. Okay, cool. So we've run that, and we've created our synthetic data set. So okay. Okay, so we have our synthetic data set there, and now one thing that we can do is, okay, in order to actually do this, or to actually check the validity of these models, or the sort of models they create, what you can do is, as long as you actually put your analysis within the context of a linear model, it can actually do these comparisons, and you can do these comparisons to actually see how well your synthetic data fits the original data. And I want to go to this amazing blog post done by Jonas Lindelöf, and basically in this blog post he incredibly outlines how most common statistical tests are in fact linear models. So in order for this to work, in order for us to actually test the validity of this synthetic data, we need to convert our analysis, we need to run our analysis in the context of linear models. So the first thing that I need to do here is basically figure out how to actually put these things into linear models so we can do these tests. Okay, so let's just start by running a Ttest of the comparison between oxytocin and placebo for self-reported spirituality. Because once we do this, then we can actually test the validity of this synthetic data set. Okay, let's do that. Ttest. This one. Now, because I use a crazy Norwegian keyboard, I don't have the tilde, so sometimes it can be hard getting that. So let's get the Ttest documentation up. There's a quicker way. Make this bigger. There we go. Copy that. Super annoying. Okay. To condition. Data equals OT. That. doing a assuming variances are not equal. Okay. What does that give us? All right. Let's have a look at that. Cool. This is a t-test. So when you're looking at that, there is no difference between the two variables. There is no impact of oxytocin administration on self-reported spirituality. All right, let's make this into a linear model. Okay, LM. Yep, that one. Copy and paste tilde. There we go there. Okay. One. See if this works. Okay, get the summary. Okay. All right, so let's compare that to A. All right, so we got a t-value of minus 1.136 and a p-value of 0.26. Yeah. There we go. The direction of the t-value was different, but otherwise, this is exactly the same. So here we have the linear model, which is essentially a t-test, and we're getting the same result. Okay. Cool. All right, so now before we created our synthetic data set, let's actually see how well it performed. I think compare. Let's have a look. The old documentation. Compare. Yep. Compare. How does this go? Compare object data. Object synthetic. Okay. So we created our synthetic data set. Go compare. OT syn. Oh, typo. Against our original data set. OT dat s. Is that going to work? Something's happening. All right, cool. So it's doing the comparisons there. It should also give us some plots to look at the distributions to see how well our synthetic data set actually matches with our original data set. Should get, there we go. Okay, cool. All right, so now we got these plots here, which are going to hopefully load soon. All right, so dark blue is observed and light blue is synthetic, and we can actually see how closely these things match. These look pretty good. For instance, religious affiliation was rated between 1 and 7 or 1 or 8. Hard to see. But you can actually see how the distribution of these things are actually quite similar. Same thing with the self-reported spirituality there as well. And of course, when it comes to the actual randomization of conditions, it's extremely similar. So you can see those things there. Okay, so that's one cool way of actually seeing is the synthetic data set actually similar to the original data set. So that is a good first step. Okay, so I think now the most important thing is, it's one thing to actually say that the data sets are similar or to visualize that the data sets are similar, but what we actually want to see is whether the models that we fit are are similar between the synthetic and the original data sets. And that is the whole reason why we created these linear models, or the linear alternative to the sort of tests that we want to do. I'm not quite sure why this is needed for the software package, for the R package, but that is how it is. Okay, so let us. All right, so we have. Let's comment our coding so I can actually figure out what I did. Comparing synthetic model against real model. Okay. Just copy and paste this down here. Okay, and then so from memory, so then we have to run. Go back to help. LMs. Yeah, there it is. Documentation. One of the biggest things that helped me out when I was learning R was actually figuring out how to read the documentation. Because once you can read the documentation, then you are well on your way. Okay, so it's just typical formula examples there. All right. LM synths. There we go. Syn. LM. Yep. Does this work? Okay. Looks like I have to do it in a different structure. Double check this again. Okay. I have to specify the data at the end. Data equals synthetic data, which is OT syn. Okay. Yes, that worked. All right. There. Okay, so now we've got a summary there, and then we need to compare these two things. I'm not sure which goes first. Object. The synthetic one goes first. Against the data? Let's find out. Hey. Okay. Wow, that's a little bit off. And I think I know why. Let's go back and explore that. So this basically suggests that the synthetic data and the observed data is very, very different. That's a lot more than I expected. So let's try. That should make a difference. Yeah, that looks pretty similar. Okay. Well, there you go. Okay. That was a lot more than I thought. Okay, so this would suggest that these models are quite different. So I want to try something else. Sometimes these things behave a bit weirdly if you're using the actual variable names versus just putting it in as zeros and ones. So it's probably not going to make any difference whatsoever. But sometimes these things work. Okay. See how we go. Okay. This is coding, isn't it? Try it again. OT. Keeping an eye on any comments as well. Send them through. Few people. Keeping an eye. Okay. Condon. Okay. Rerunning stuff. Checking that this has... Yep. Okay. Okay, so let's see how we go on here. All right. This is hard. Who would have thought coding live would be hard? Okay. So let's create the seed here. Cool. Now we've got the number in there. And let's try making this accept. Do it this way. Six. Okay, that looks pretty similar again. So that didn't make much difference whatsoever. Okay, so it looks like, at least for this condition, there are some similarities, but there are also some differences. So let's just... I doubt this is going to make a difference. One thing that you can do is that you can actually create a number of different synthetic data sets. So you can create 5, 10, 20. You can actually aggregate that. It's probably going to make no difference whatsoever, but let's just see if changing the seed around, it seems a bit hacky, but I'm trying to learn how this thing actually works. Because if it's that sensitive to the seed that you choose, and that's a bit weird. Okay, so that looks a little bit better. Might have to look into the documentation a little bit more to actually figure out what the impact of that is. But essentially, for the actual statistical test, it looks like these things are at least compatible there. Okay. Now, the original test, let's go back to this one here. The original study that looked at oxytocin and spirituality actually explored an ANCOVA to include the covariate of religious affiliations. So what we're going to do is we are going to try and do that ANCOVA as a linear model as well, because that was the main outcome. So you'd hope these things would be similar. Okay. But I might come back to that because that's a bit weird. I would have thought that the that would have performed a little bit better, but that's how these things go. All right, let's run a traditional ANCOVA. Do we have car installed? Probably. No. This one here. Yep. Plus this measure of religious affiliation. Let's have a look. Paste this in. All right, so this should be our ANCOVA. Oh, got my bracket. Data. There we go. Okay. There is our test there. Okay. All right. Seems about right, I think. Anyway, okay, let's try this as a linear model. LM. See how this goes. Paste that in. Always forget the summary. Okay, I'll compare that against that. Now to get that comparison there, let's just try something. We'll create a null model. So we can actually compare that against the full model and remove religious affiliation. And then do an ANOVA comparing this against this. $22.62. 22. Oh, it's pretty close. It's pretty close. 22.66. Oh, it's the same. Yeah, cool. Okay. So this linear model gives us the exact same outcome as the ANOVA. Okay, cool. Now, let's do the same thing again and see how well this model performs. Do some copy pasty. New name. Get the model in. I think I know what happened last time. Oh. Okay. Okay. Let's see what has happened here. So we're trying to compare our ANCOVA linear model, or the equivalent of the ANCOVA linear model, against the actual one. Synthetic against that. What does this plot look like? See what happens, hey? Sometimes R can be slow, or maybe I've done the wrong thing, and the last one is probably more likely. Alright, let's just try that again. It's working away, doing its thing. Okay. Alright, so now this has looked at the model fit, and they look okay, but not great. But then we can actually see the p-values, the differences between the results based on the synthetic and observed data. So there seems to be a difference with the impact or the covariate of religious affiliation. All right. Now what I want to do is spend some time looking back through the documentation. A bit boring, but this is what you have to do. Yes, there's another example of the comparisons, at least from the documentation, between the observed and synthetic data. That was kind of what I was expecting, but I have a feeling I've done something wrong. Okay. Let's go and revisit this. Okay. Create the seed here. Synthetic data set, seed, Ttest. I'm just going to confirm that this gives us the same values. 1.14. 1.14, yep. When we compare these two things, running it all again. Compare it again. Sometimes you just need to go through things line by line to figure out what's going on. Okay. Oh, is that missing value messing? Missing value down here. And maybe that's messing with their analysis. Okay. Trying these comparisons again. Yeah, not great, but it is not too bad. Okay, and we've got our Ancovers. Let's have a look at correlations. One of the original tests that I did in my tutorial was looking at the correlation, I think, between self-reported spirituality and age. Yeah. So, document. Okay. Goes core.test. Yep, with that one. Okay. 0.75. Let's have a look. What does that look like? I think it'll work. Let's find out. Nope. Of course not. All right. Scratch that. Okay. Let's have a look. Create the synthetic version. Oh no, linear version. Okay. So going back into this amazing resource. In order to get the same R value, you need to do this. You need to scale it, or scale your variables. So you can still get the same outcomes, or the same p-value, if you're doing just a straightforward linear regression. But in order to get the same R, you need to do scale. Okay. Okay. See if this works. Probably not. Let's find out. Something happened. Summary. Cool. Yay! 0.314, p-value 0.75. 0.314754. Yes. Cool. There we go. Few losses, small wins. That's looking good. Okay. There we go. So now what we've done is created as per these instructions, created a linear model equivalent of a Pearson correlation. And by adding this, by scaling your variables, you can actually recreate your Pearson's R, as well as your p-value. That is cool. Okay. Now, let us go back. And see if we can follow the documentation. LM sins. Okay. Core sin. LM sins. I don't know if this is going to work, but we'll try. Yeah, okay. It's that old problem again. Age. That. Data equals. That. Ttest. Synthetic data. Yep. What is the name of our synthetic dataset? OT-syn. Okay. All right, so original summary. Of course, always forget. Always forget. Let's do a comparison. Let's see how this plot looks. Okay. That's pretty much spot on. So when you're comparing this linear model, which is looking at the relationship between age and self-reported spirituality, the values between the model from the synthetic data versus the model from the observed data is almost spot on. P-value 0.97. It's pretty good. There you go. Okay. So for those correlations, that seemed to be pretty good. Okay. I just want to try this again. Something bugging me about this Ttest. Yeah, still the same. Okay, so when it comes to the correlation, these models look pretty similar. Okay, that's pretty good. All right, so what we've done so far is... What I've done so far is imported the data. I might wrap up for this section, but I'll give you a bit of a summary. Imported the data, created the synthetic data sets, which look fairly similar from the original data set. And in order to actually test how these models would work, I've converted some of these statistical tests into linear models, which seems to have worked, but I'll need to double check. And then compared the two. T-tests didn't perform great, but the ANCOVA and the correlations seem to do well. Okay, so I might wrap up, and then maybe I'll come back later this afternoon because I'm really hungry and it's time to eat. I'm going to grab some coffee. But yeah, if you tuned in, thanks for watching.